Hello, and welcome back to... Wait a minute, this is Las Vegas. I'm James, and this is Will of Team HyperShock, and we're at the BattleBots competition. Hey, Will.
How's it going?
Doing great. How are you doing?
Doing pretty good. Doing pretty good.
Cool. So, what is this thing here?
This year's HyperShock. This is our 250-pound fighting robot on the TV show BattleBots. It's a bright yellow blur that goes across the screen and rips people up and does donuts in the process.
All right. Cool. So, I'm going to ask you some questions about the bot, but I wanted to ask a few questions about you and Team HyperShock.
Sounds great.
So, is this your first year in the competition?
This is not. We've been around since the reboot back in 2015.
Wow.
So this is our 7th season.
Okay. And then how many iterations of the robot have you done since then?
6. So we used to make a new one every year.
Okay.
But last year we finally, when you know, you know, and we finally hit the sweet spot. And so this is basically last year's robot with a couple little tweaks here and there. But otherwise, it's the most destructive winner from last year.
Nice. That's a good title to have. Do you guys have that on a t-shirt?
No, but we do have the 3 bolts that we
Nice. Okay, so I have a couple of questions people have asked me, and I promise you, these are not my questions. The first one is, are you ever afraid of the thing that you built or what it might do to humanity one day?
In general, am I afraid of it? Yes. Am I afraid of what it'll do to humanity? Well, the batteries only last 3 to 5 minutes, so I think we're safe. But those 3 to 5 minutes are going to be really stressful.
That's gonna make for some great stuff on Instagram.
Oh, yeah.
If you had infinite time, is there one thing about this version of the robot that you would change?
Oh, man. If I had infinite time, do I have infinite resources too? Why
Yeah,
not?
why not?
I don't think there's really much I'd change. I think we've really hit our stride here, and it's what we always wanted HyperShock to be. It's not the brute force most competitive, although it's doing pretty well, and we're really happy with how it does perform. But first and foremost, this is a passion project for us. We wanted it to look cool. We wanted it to satisfy those fun project urges that you get when you're working, you're tinkering on a project, and it definitely scratches the right spot.
That's cool. I really like the look of your design. I think you guys have an awesome shot, and I can't wait to see it perform.
That's gonna be a good one.
So before we do that, can we take it apart?
Sure. All right, so this is a HyperShock. It's a very sparsely filled HyperShock. The way we've done things is we've gone kind of modular with how we do the construction, so it's quick to put together, quick to take apart. So for example, this is a drive module. So we got a motor. We have a magnetic encoder for the motor. It's an AS5147P encoder chip. We have the receiver. It's all RC control. So this is a Spectrum receiver. And then this is our motor controller.
Okay.
It's a Trampa VESC 75300, if you know about VESC brushless motor controllers. And so this thing is something that we can drop in a robot and be good to go. We have a stack of them on the shelf. And so we have a whole bunch of left motors and a whole bunch of right motors. And when you got to throw a robot together, it's really nice and quick. You just drop one in, grab the chain around, add power with 2 lugs, and you're good to go.
Okay, so these are different for the left and right?
It's the same assembly, left and right, but we...
okay, it just has to be mirrored.
Yeah, for radio signal mixing, we have half of them set up as left sides,
okay,
and the other half is right sides.
Got it.
So that we can just grab them and throw them in, and we know it's going to work.
Okay. Now, I heard it come up a couple times today, specifically mentioning brushless motors.
Brushless motors.
I know a little about the difference between the types of motors, but what's so special about brushless in terms of an application like this?
All right, so the 2 kinds of motors you're going to see at BattleBots are brushed or brushless motors. In the past, brushed motors were tried and true. They're very robust, very easy to control. You can use a contactor. You just apply power and it works. But the brushes are a rare item, and they are not particularly efficient, so they get really hot. And you'll see, the teams that still have brushless or brushed motors, they'll have piles of these burnt carcasses of motors because they just go through them so quickly. So in the last couple of years, people have started going to brushless motors, but leveraging a lot of the hobby technology that's been out in recent years, and just trying to make it work because it's pretty darn cheap. Electric longboard electronics have been incredibly cheap recently,
That makes sense.
and that's what a lot of people are running. So we have brushless motors too. a little bit more complex electronically because you have to have a brushless motor controller system because it's a three-phase motor. And we have encoders for position sensing for that low-end torque. Some people use Hall sensors.
Are the encoders external?
Yeah, so it's an external encoder. So it's right here.
Okay.
We have it's a magnetic encoder, so there's a magnet pressed into the axle on the back end, and so the chip is seeing whatever the rotor position is. The biggest challenge that people have had with brushless motors is low end torque. In terms of power and efficiency, brushless is great. But the real Achilles heel has always been that low end torque that brush motors always had. So there's kind of three schools of thought. There's sensorless, which doesn't work. It doesn't work.
I can't imagine that working at all for a BattleBot.
Don't waste your time. There's Hall sensors, which a lot of the hobby motors come with anyway. And then there's magnetic encoders, which we've gone with. A lot of the top tier teams have gone with if they've had the time to put the development effort in, and it works really well. So we get that low end torque that you like with brush motors, but we're getting the efficiency and the power density that you love about brush tools.
Okay, so this unit is here.
So one of these goes here, and one of these goes there for the drive, and then the same parts are just kind of separated for the weapon.
Oh, of
So
course.
if I can
the
find
important
a
thing.
weapon motor. So you can kind of see it in here. So for the weapon, we have two of the same motors back to back on a common shaft. We did that for redundancy of the motors. We know if there's a jam, that's a failure point, but can't have it all.
Right.
And it's already saved us because we've lost a chain in one of our matches. And thankfully, because we have the two
other
chains
one
on the same shaft, it still worked with full power.
Okay.
So we have two motors on the same shaft, the same motor controllers from the drivetrain, the same encoder chips. It's all the same. And then we have a slip clutch with on either side for the sprockets, so that if there is a massive hit, the chains will slip and spin a little bit before the magnets and the motors explode.
Which is usually not a good thing, right?
No,
it's great
no,
for
no,
the
no.
camera, but
Fantastic for the camera, not so good for the robot.
right. Okay. So I really like this, and something I hadn't thought about is how many of these components that you're repeating the use of, right? Like in my mind, I would have thought your drive motors and your weapon motor would have been different for whatever reason.
And in a lot of ways, you want different things out of them. Like,
Right.
For example, our drivetrain, we're pretty fast as robots go. We go 25 miles an hour. But the weapon at the tips of the teeth, it spins at 200 miles an hour.
Right.
So we have totally different gearing.
Okay.
There's a very different load on these motors. But fortunately, with this motor and controller combo, we found something that was good at both jobs.
Right.
And yeah, like you said, it makes it a lot easier for swapping out parts, keeping spares.
Right.
And so for us, it was an important progression off of previous seasons where we didn't do that.
Okay.
And we've loved it ever since.
Yeah, I can see a lot of advantages. So cool. I didn't realize when I saw the bot running that I thought it was 4-wheel drive,
Oh yeah.
and I guess it's not, right? Because you're just got the two drive motors and then they're chained together.
Right. We are chain driven. So we're using chains for production and power distribution.
Right.
So we have a first stage that goes from the motor to this jack shaft. And then on the inside, so it's well protected.
Yep.
And then on the outside, there's a chain that goes to the back wheel and a chain that goes to the front. It gives us a little bit more redundancy in terms of drivetrain. We've tried separate motors for the front wheels and for the back wheels in the past, and there's some other robots here that do it. But especially with a vertical spinner, it's so forward heavy that you're always loading the front motors more.
Right.
So I'd rather distribute that power evenly.
Yeah.
It makes better donuts.
Well, I mean, there's certain cars that are done that way as well, right?
Right.
The weight's distributed that way.
It's
So
it's an all-wheel drive system.
Right.
In this regard.
You had talked about the RC electronics just a little bit. So are you really just using something from an RC?
Yeah.
Is that?
Yeah, I am. We are using Spectrum transmitters and receivers.
Oh, wow. That's what
from
I've got
RC cars and stuff. So
holy cow.
this is what we use. So there, you hold
Oh my
the
gosh, this is
transmitter.
exactly what I have.
Yeah. So it's a DX9 Spectrum. We've had it for
Yeah.
quite a while. And then this is my DX4R transmitter. We've had it since season 1.
Okay.
It works. I like it. It's robust, and
That's just
I was an RC car kid when I was growing up, so that's why I like pistol grip. I can just pull the
Yep,
trigger,
yep.
no matter how many pre-fight jitters I have. Doesn't matter if I'm shaking. I can just pull the trigger and it goes straight.
yeah. Nice.
Yeah.
This is so cool because, again, I just imagine you would have something more elaborate or customized, but
some teams have tried.
Yeah.
Like Ribbon, for example, has a impressive telemetry system.
Okay.
They have made their own custom controllers and all sorts of wacky stuff. They did a super high voltage system last year, like 200 volts DC.
Okay.
It was ridiculous.
For the drive motors?
For everything. It was a whole thing.
Okay.
But yeah, some people have done more elaborate control systems with telemetry or something like
Yep.
that. The fact of the matter is, this is a 3-minute fight at the most.
Right.
So what do you? Let me tell you this. Your left weapon motor is burning up. What you gonna do? You gonna turn your weapon off?
Yeah. Right.
I'm not gonna turn it
No,
off.
you're gonna go. It's gonna go till you fail, right?
I'm gonna go until I fail because I'd rather keep get one last hit in
Yep.
there, and it goes up in a wall of smoke rather than missing an opportunity.
And that's something that I've found interesting watching matches is I think in the industrial world, you would shut things down really early, right?
Mm-hmm.
And in this situation, it's like, even if you think you're going to lose, you might as well, like you said, just let the weapon keep going because you don't know, you might score a hit, right?
It's worth the chance.
Yeah.
It's funny seeing some of the things that new teams do. A common one is put a fuse in there or resetting fuse.
Yeah.
Well, the fuse is cheap, and I respect that because Lord knows these things are expensive.
Right.
Especially if you blow up a motor controller, it's $500-600. Yeah, go down to the Home Depot and grab yourself a couple.
Go get a new fuse.
Go to Avnet. Go get some multi-comp pro fuses. But what are you going to lose?
Right.
You put all this effort in, and you're going to lose a match because you wanted the fuse to go or it accidentally goes.
I won't put you on the spot, but if I were a team that lost because of a fuse, I would be heartbroken.
Yeah.
Because exactly for what you said, it's like, well, I'm sure beforehand, saving the electronics or the expensive parts totally makes sense.
Yeah.
But in that moment, you'd rather let it go.
Especially when there's nothing else wrong.
Yeah.
We had
if it was just an overload. Oh gosh.
And especially when these motors are running, we have 250 amp limits on all these motors. So we have 1,000 amps going through the motors when we're box threshing somebody and spinning up the weapon. What are you going to use? A bar of brass as your fuse?
Well, you drill holes in it, and then that's how you configure how much current it can handle.
Calibrated holes.
Yeah. So. Okay, so I'm noticing one thing that's missing from this, other than the obvious shell
Couple
pieces. Where's the batteries?
So the batteries are outside. So here at BattleBots, no lithium batteries are allowed inside the pits for safety reasons. But we do use lithium batteries. We're using a 16S system, so it's nominal 60 volts. It's about 10 amp hour. It's a 9.9 amp hour pack. So it's a whole bunch of smaller lithium battery packs that we're buying from a company called Thunder Power, RC. A whole bunch of
RC components,
right?
Yep.
And we gang them together and we craft this box. Yep. So we welcome to the HyperShock pit. It's very messy.
That dent was there before I kicked it.
So we have a battery box,
wow.
just like this, and we put them all in.
Is this 3D printed?
Yeah, so it's a 3D printed box.
Carbon fiber?
Carbon fiber lid, 3D printed Ultem 9085.
Okay.
It's high temp. And so what we do is we have some custom connectors. We went on to Newark and we bought a whole bunch of, I guess they're, oh goodness, I forgot what flavor, but they're circular connectors, contacts.
Yeah.
And we made custom connector housings that we screw them into the battery box. So we have this thing with all the balance connectors on either side.
Oh, wow.
And you just drop it in the robot.
Yeah.
And it's very easy from a usability standpoint. Just quickly drop the battery box in.
Yeah.
And then at the end of the match, when everything's on fire, you quickly rip it out.
Right.
And then we have a charging station that's set up to receive
Do the same thing, right?
You just drop it in, hit the button, and you walk away.
That's brilliant.
So
is this like, are these just to pull out?
These are our pull-out hooks.
Okay.
They're titanium.
Yeah, I just wasn't sure
pull-out
because they
hooks.
almost look like they're thick enough to carry current.
Oh, not quite. And we also have this this is the weapon motor controller tray.
Right.
And it actually clicks into these. So this is a dual purpose.
Got it.
Just to try to
Very nice.
eliminate some screws.
That's really, I think that's really inventive. I think when I think BattleBots, I think pieces welded together, bolted together. It's almost funny to see that one of the critical systems has a 3D printed component to it.
There's a lot of 3D printing here. We have a 3D printer behind us that we brought. We have a Mark IV Sonics that makes
Nice.
great parts. We have moved away from a lot of 3D printed parts just from robustness and modularity standpoints, but there's still lots of little 3D printed things in here.
Yeah, I can
and
see
in other
that.
robots.
Yeah.
It's a great technology if you know how to use it right.
Right.
Lots of people are using TPUs and using hobby grade printers with great success to make shock mounted mounts for motor
Really?
controllers and things like that.
I guess that makes sense because what else? I mean, to make something custom that's casted or something would just be
right. Yeah, you might.
endlessly expensive. And then if it's not what you need, what do you do?
Yeah,
If it doesn't fit or it doesn't absorb as much as you want.
or you need another. Yeah.
Yeah. Have you guys used the power supplies to
Oh
simulate
yeah.
the battery?
Well, we're not allowed to have batteries in here, so thankfully we actually have some multi-pro power supplies that let us do all the testing, all the setup in the pits without having to schlep everything outside. It's one of those frustrating things about being at BattleBots is for safety reasons, it's too high a risk to have a
Right.
lithium battery fire in the pits. From having all the people here, there's filming going on. You can't just suddenly evacuate this because a little LiPo pack goes up. So having some benchtop power supplies that we could crank up all the way to 60 volts and can give us the power we need to calibrate all these motor controllers, it's a huge boon, and people come by and borrow them all the time because it's much nicer to sit here in the air conditioning than drag everything out to the battery box, battery tent. And it's crowded in there and it's not as comfortable. And it's just better.
So in terms of testing, then I would imagine in here you can't test the weapon.
Right. Yeah.
so and I'm just kind of curious now.
Yeah.
So you mentioned like calibrating the motor controllers. So is it really what you're sort of limited to is just testing the drivetrain, or?
So what we'll do is we'll take the weapon chains off, and then
Okay.
we'll calibrate the weapon motors here.
Okay.
So we'll do everything that doesn't spin a scary thing.
Yes.
In here as much as possible. Yeah, it's too dangerous to spin this up in here. You want to do that
anywhere
in the test box.
except for.
Yeah. Do not try this at home. Good heavens, no.
Well, it doesn't look very sharp.
Yeah. Well. Yeah. Yeah. I already got a couple cuts.
Yeah.
from
No,
Sean
I'm not
the
even
other day.
going to pretend. I'm not.
Yeah, they're nice and sharp. We like them that way.
Yeah. My last question about the bot.
Absolutely.
Is there anything you wish people would ask about it but never do?
Oh man, what do I wish people would ask?
I should have asked him that beforehand, so he had a good answer.
It's a question we get a lot, so it's not the question that we don't get asked, but people ask all the time, why don't we protect our wheels?
Fair
And I
question.
love answering it. So HyperShock, one of the big things is these massive tires.
Right.
They're very flexible. They're nice and chunky, and they look like a great thing to bite on if you're an opponent.
Yep.
The fact of the matter is, we're all limited to a 250-pound weight. So everyone's, right at the edge. And so we can protect the wheels, we can protect the rest of the expensive stuff inside, and we can have a weapon. Fix it.
Yep. Yeah, you can't
So
do
we'd
them
much
all, right?
rather, leave these out, going in the wind, because we have 4 of them. We can lose 2 and still win a match.
Yeah, actually, I was just thinking about that with the way that you've configured the drivetrain. You really don't need all 4 to be successful.
Right, and last year against Lockjaw, they tore off the left one, they tore off the right one, and by the end of it, we're scooting around with the rear wheels, worked just fine.
Yeah.
And they also kind of act as little keep-away hands from all the other big scary weapons. So I'd much
that's
rather
a good
lose
point.
a tire,
Yeah,
which is $150, than the chassis or a motor, which is so much more expensive and so much more difficult to replace.
Yeah, I'm thinking from a design perspective, you've got a component that's relatively inexpensive, it's easy to replace, and it's redundant.
Yep.
So if you're basically going to show a soft underbelly,
Yeah, if you've got to pick one,
yeah,
pretty good.
makes sense.
What would you like to know about HyperShock?
What's its highest speed?
Oh, good question. So when we're driving around, HyperShock can hit 25 miles an hour. So when we're doing those donuts and stuff, the wheels are spinning 25 miles an hour. The weapon, however, this puppy spins at 200 miles an hour. So it's going 4,000 or 5,000 RPM. And then when we hit other people and parts come flying off, and yeah, it's exciting.
Have you ever been in a car that goes 200 miles an hour?
You want to hop on?